Hello everyone, welcome to a video on code tech and tutorials. Today I want to talk a little bit about return values and function values in C++ and just give a little overview of how they all work, the options you have. So we're going to open Visual Studio 2019, create a new project. Let's just leave it empty. We're just doing C++ here, playing on C++. And I'm going to call this, I don't know, I guess just return values, that's fine. Okay, create it. And we're just going to get a plain old C++ project setup that compiles with Visual Studio compiler for C++. And first of all, I'm going to change this to show all files. Show all files. And there's no files in here. So we have an empty project as we intended. We're going to not put this, we'll leave it in debug and X, we'll put it in X64. I guess it doesn't really matter a whole lot for our case. And we're going to add some C++ files. And new item. And sure, we'll just make a, well, we want a main. It just defaults to source on this. So I'm just going to put a main in this source file and it'll figure it out. Let's just hello world this. So we should just get a hello world. And that popped up so fast that we couldn't tell. So all we can do if we want it to stop is go just char and then cn. Standard cn that char. Oh, it'll stop us at this prompt. There we go. So we just need to hit enter basically, or enter a key and press enter. So that'll stop us at the end. Okay, so return values. When you want to get something back from a function, or you want a function to modify a current variable, that's often when you want a return value. Let's say you're making a game and you have a function called damage. Do damage. And on this we want a float of an amount of damage and we want a target. So the target will be, for now we'll call it a actual target. Okay. So now it needs to know what target is, and we'll just say struct target. And it has double HP or hit points. Let's make it a float actually. And we'll say it starts out with 100 hit points. Just by default. So if you don't specify, it'll have 100. And this DoDamage function, we'll go ahead and define it up here. It just takes this target and their hit points, and it's going to minus it by the amount of damage. Takes whatever is on the left side and minuses it by whatever is on the right side. So it'll actually modify this value. So the problem here is this target will probably come in as a copy unless we put a reference symbol here. And I say probably because you kind of have to in C++ because every compiler can do something different. If you're on the same compiler as me, I can tell you what will happen. But if you're on a different one, I cannot tell you what will happen, especially if you're on an older one, much older one. Okay, so what we want to do here is pull it in by reference. That way it tells C++ to pull it in by reference, and it's an actual reference to the actual variable, and then we can access that actual target, the real thing, not a copy, and its hit points, and subtract it by the amount of damage. The amount of damage is also going to come in as a copy. In this case, that is fine because we're not going to modify it. However, we can make it a little faster by pulling it in by reference, and we're not modifying it, so it's fine, right? Well, let's just make sure this never gets modified because we don't want it to here. Do damage only does damage. It doesn't affect the amount of damage. So we make it a const. And that way, if in any case someone tried to edit this amount of damage that came in by reference, they'll get a compiler error. But in the meantime, it's faster because it's pulling it in by reference and not having to make a copy. So let's do a few things here to choose actions. So let's attack. So we'll make a little switch to handle this, and we're going to do some damage. We need a target, so we're going to have to instantiate some stuff for the game. So let's make a target called initial target. And it's going to come in with 100 hit points because that's what the default constructor will do. How much damage do we want to do? Let's just say we're going to do 100 to this initial target. Now some things will happen based on this damage. Target may be reduced below 0, or it may not be. So we might want to spit out a message, and we could do that right here in this DoDamage, or we could have it handled somewhere else and leave our DoDamage nice and pure, because we know that this should work 100% perfect for subtracting that amount of damage no matter what from the target's hit points. As long as this is not a copy, which it isn't going to be unless we make a copy ourselves before calling it. Maybe we need some sort of result. So we could check the initial target's hit points afterwards. So we could go something like this. Target died. We could also spit out the damage inflicted or something like that. What might be nice here is actually to call a after hit routine to like log the damage and spit out any relevant messages. After damage. Yeah, we'll say after damage. So we could take this in again. This target this time is going to be const because we don't want to edit it in the after damage triggers. But we do need to know about it so we can check it. So we'll basically take this code right here, paste it in, and we can get rid of this. And we can just call after damage right here with the amount of damage and the target. So when this gets called and the target becomes const, it's basically going to do a const cast to go from mutable to unmutable. So the target will now be unmutable in this after damage. And we want to do it that way basically in case we have code we're writing every day, maybe other people working on it, and we want to make sure that the target never gets modified in this function because we don't intend that to be part of our workflow and design. So a lot of this stuff in code that you will learn over time comes back to design. I think it's better to study a lot of design before even coding at all, because if you know exactly what you're doing, things will pop out to you when you come upon them in code or in documentation, like, oh yeah, that I know where I need that. The hard study, soft study philosophy. So we want to say if it died, and we want to also do other things. What else do we want to do? Now, the target here. So we're trying now to just standard console out the target. Console doesn't know how to handle this because it's a struct, but we can tell it how to with operator. Nope, this does have to be a friend. And there we go. And now when we do damage, we should get a note of the after damage. We should get an amount damage inflicted on, and we should say target died if it died. And we'll just put this in a while loop so that we can do it over and over until we're done. We'll use an int. Yeah, let's see, 0 is going to be false, everything else is going to be true. So we'll start it out at 1. So we'll enter 0 to quit. If running becomes 0, it'll be false and it'll be a quit. It's pretty standard for an integer. So we could just put another thing here like 99 is quit. So then we'll just have this if choice equals 99, running equals 0. That way this will make this false on the next loop. So we have a way to quit. And we no longer need this character thing at the end. Let's go ahead and run this. Let's see if it works as we expect. After damage identifier not found. So, okay, because of how we're declaring them and in the order, this is the program's actual entry point. This is the first thing it sees. So at this point, it doesn't see after damage. It doesn't know what it is because it hasn't been defined yet. So let's move this above it, above damage. And hit play again. And there we go. Pops up, asks us for an action, so we can attack or quit. Let's go ahead and hit 1, enter, and attack. 100 inflicted on base actor, choose action. Attack again. 100 inflicted on base actor, target died, choose action. Okay, so it died that time. It didn't die the first time because we're checking if hit points is less than 0, and it was exactly 0. Let's try the quit. Just make sure that works. Quit. All right, it actually quits out of there. Now that we've ran it once, we'll see some things we want to clean up. Just say a target. Only member functions and bases can be virtual. So because this is a friend, it can't be virtual. So that's something. How do you make a virtual OStream operator? Looks like someone has asked this before. It's a pretty old question, but it is really quite relevant to what we're doing. Okay, looks like we need to make it const. That's the big thing. And not a friend. And it looks like we can't take in the target. Which makes sense, because since it's now not a friend, but rather a member of the class, the target is itself. Okay, now this doesn't like this spitting out the target, so let's see how we are supposed to use it now. It as the OStream part. Oh, wait a second, that's really weird. Seems backwards. Okay, so we have to put, let's see if I've got this right. We'll have to go target, spit out standard, cout, and then a new line at the end. Okay, this feels really awkward to me. I don't think I've ever done it in this order before. So, but it does seem to compile. So let's go ahead and do an attack. And now the target does die. And we did inflict the 100 damage. Okay, very good. So we'll go ahead and quit there. Let's recap. Okay, so we learned that, well, this is the return value. We learned a lot of stuff. I talked about a lot of stuff, but the main thing I wanted to get into, and I just kind of over-explained other things while I was at it, is the return values. And really the point is you can, rather than processing a return value from this side, you can have this do some other thing. And what you want to modify, you can pass in as a reference. That way your function has access to it. You have to be very careful with these sorts of functions because they are literally modifying data from the rest of your code base. So you have to be sure what they're doing isn't going to mess something else up. And that's why we're starting with a really simple case. There are some overflow problems here. You could do so much damage that the target's hit points go out of the range. So there is those sort of concerns. But we didn't address that here. And I don't think there's really a need to in a simple demo case. But you should be aware of overflowing variables because it does crash programs. There are ways around that, always. You just have to code it up correctly and think about large numbers ahead of time. So we're allowed to modify this target, and that essentially is a return value, because while we're not directly saying return it, we are taking some known thing and modifying it as the same we could do by returning the results and modifying it in code. The references have to be actual things. If they don't exist, the code is going to have an error and do all sorts of weird stuff. So it might be a good option to pass this in by pointer. If you pass it in by pointer, is it a copy of the pointer? So if a pointer is passed to a function as a parameter and tried to be modified, then the changes made to the pointer do not reflect back outside the function. This is because only a copy of the pointer is passed to the function. It can be said that pass by pointer is passing a pointer by value. In most cases, this does not present a problem, but the problem comes around when you modify the pointer inside the function. Instead of modifying the variable, you're only modifying a copy of the pointer, and the original pointer remains unmodified. Okay, so yeah, it actually would work because you're still pointing to the same data, and you can also check for null in these cases. So let's do that instead. And here, when we're passing in again, we're going to do it as a const pointer, which will still make another copy, but at least we know it can't be modified, so the compiler could optimize more if it wanted to. I think we have to dereference this, and there we go. We can now check for null if we want to. And initial target, we could make it a pointer now, but then we also have to allocate it. We could even just do it like this and leave it uninitialized, and that would be it would pass in here as null. And the problem with that is when we do this DoDamage function, this could all be null. So we actually want to have a null here, check here. And to do that, we'll just say if no target, basically if not target, because this would be just like this is if it exists, which it's anything but null. This will come back true. But if we want to say it's false, go into this loop. We have to put a not symbol. I know that's confusing, but this is the same as if target equals null. Null pointer. I can see the advantage of the readability of target equals null pointer. So we're going to leave it the more readable one now, for now, since this is more of a demo. So now if the target is null, we could just not do the damage and we could just return. It might be nice to spit out a message, target is null. So, and let's just go ahead and run it with null. And it still complains. It won't actually let us compile uninitialized local variable. Fine. We'll initialize it. And there we go. Still works the same. So we now want a return value, and let's make this an integer. So now we can take advantage of this. Rather than it being void, we can now have this return an actual thing. It might actually make sense to be some sort of damage results. Yeah, let's say this, damage results. And then we'll make a struct. So if you want to return something specific, something that's not just an integer or a float, but has multiple values, you can make it a struct. So we can make a struct here and call it damage results. Damage results. We'll have them both handle it. So after damage is going to return the final one. So what we'll need to do here is we'll need to make the variable. So we'll make damage results right here, instantiate it, and we'll just call it results. And now we're going to make this equal to whatever after damage returns. And then we're going to return it. Optionally, rather than worrying about all this, we can just, okay, then we're going to return it. So there's 3 lines there. It's complaining probably because damage results hasn't been defined. Incomplete type, right. So we can do that and make it a complete type, just defined as nothing. But maybe we want to have a string in here. No, we'll have an enum in here. This is going to be weird. So we'll say alive, dead. Well, just dead and alive is fine for now. It's either dead or alive. So target status can be dead or alive. Now later we might want other things in here like searching, you know, depending on AI, sleeping. But right now we're just going to do dead and alive. In this way we can just populate all this here with what we want to say. We'll just work up these logs a little bit rather than doing so many couts. Okay, so I'm going to do target status equals dead. And it doesn't know what that is, so we have to dig in a little here, and we're expecting it to return from after damage. So let's instantiate it in here. And we'll just return it entirely. So it'll return the result of after damage. So we got the null check, we have it actually do the damage, and then we have it return the results of the damage. Now it doesn't see this dead here because we need to preface it with target status, and it still doesn't see it because it's within damage results. Struck like that, since it's public we can still see it, but to get to it we have to scope to it twice. So it's a little weird because of that, but other than that it's fine. Of course target status comes from results dot target status, so it's the one we instantiated. We don't have it set to a default. I think it'll default to dead. So we'll set our result log to be whatever this message would be basically, and we can do that with a string. We can basically set this amount of damage to a string, to string amount of damage. Oh, we need to include string. Oh, we need results.result log. So we're actually accessing this variable here. Seems to be fine. Then we can just append. We can just do the same thing, do a plus equals, and we'll do put damage inflicted on, which is, this is a const char, but it should be able to handle that. And then we just want this target name. Yeah, we don't really need this OStream thing anymore. We would have to declare a string stream to get this out, so it's a little awkward at this point. So maybe we just want something like standard. We'll just have a string handle it just for simplicity's sake. And we'll just call it name. Default name is a target. And now what we can do is we can just see out the name here. But if we're not using the see out thing, we can just get the name since it's public here on the target. And in that case, we'll just add that to the results log, the name of it. Results, result log plus equals target name. And that's a dereference since it's that pointer. We've already done the check for null pointer by the time we call after damage, so we know that it's target's not null. Okay, so this should work. I think we're just going to want maybe a new line. No, we don't want any new lines. We'll let the user handling the results log deal with new lines. We'll just populate them one at a time. anytime they do damage. Okay, so now after damage, rather than spitting out messages, we get a results log of damage results. So we do damage here, and we got to do something with the results log. So this do damage is going to end up returning one. We're going to need one. Results, damage results. So we'll declare one right here, and we'll just set it equal to whatever this do damage does, whatever it returns. So that'll run the function, hit him for 100 on the initial target, bring in the results. So what we can do here is we can now process results, and we could do it all in line here. Since damage results is a struct, we have to check specific things on it. However, we could just look at this target status. So we could switch on damage results target status. And then we have some different cases. We have, now this is going to be weird because these are long damage results, damage, target status, dead, break. Ultimately, we probably want to spit out this message, the results log. I'm going to rename this Control RR. It's a very nice refactoring tool. And Visual Studio, to double click on something, Control RR, and then rename it to like message. Yeah, I like message better. So in any case here, we're going to spit out the message, and that is damage results dot message. Did I spell it wrong? There we go. And we know we need a new line here. So that way, if we end up moving this all into a class of its own, we don't want to have to include cout in that class. We'll have that only if needed in the instantiation. Okay, so now we do a couple different things. We could say if the target died, we'll say running equals 0. We'll just quit the program. Is this the only thing there? Otherwise, we'll leave it the same, do nothing. So I really don't need this break here because default also does nothing, but whatever, it doesn't matter. The kind of the point of this is to show you the switch statement. Ideally, you would probably have a function here, like process results, and pass in the results by const reference, and then do all the switch statement stuff. So let's just do that. Process damage results. That way, the point is kind of to make our instantiation code as simple as possible. And this behind the scenes code do all the complicated, long-winded stuff. So let's grab all that. And what we're going to pass in here is damage results. Let's go ahead and make this function. Process damage results. This one might be more specific to our game state, because our game state is going to do all the handling of when we quit and stuff. So maybe this returns. Okay. Yeah, this will be fine. Make this void. We need damage results here. We don't want to edit this damage results here. So we're making a const reference. of DMG results. I don't know, I haven't really thought this through, what to do with these dead and alive cases. Ultimately, we'd want to destroy the target or whatever, have the target drop its stuff. So maybe drop stuff is what we would want to do here. But for now, I'm just going to do nothing. And we just spit out the message, really. So I think that's all we're going to do in this case. And rather than doing all this, make instantiating results and then passing it in, we could just take, since this returns the damage results, we could just put it right there and simplify that a little bit. So now we have kind of a cascade of functions going on based on our return values. Since this one returns what process damage result wants, it works. Let's go ahead and hit play. Just give it one last run. Looks like we have a function error here. Okay, after damage needs to return a value. We weren't actually returning at the end of this, so that's our problem. Return results. That way the DoDamage can return it, because after damage returns it to DoDamage, which is calling it right here at the end. Let's go ahead and hit play. It's complaining about something. Oh, I'm not returning anything here. I guess we could return. Oh, this is actually somewhat tricky because this is expecting this actual damage results to process. So we can't just return nothing. We need to return something if we're going to return. We could just, we never want to pass in a null target. If we're ever doing that, we're doing something wrong in our code. So let's just call an exit right here after spitting out the target as null message. And maybe we could stop the exit right here with just this little CN hack. That way we make sure that the user sees this target as null message. So we'll do it that way. And it looks like we're missing a bracket somewhere. Do I have to have breaks in here? Did I miss a bracket up here somewhere? Oh, I guess you need breaks. You have to have at least one break in your switch, I'm guessing. I didn't realize that. I guess I've just always had a break until that final case there. All right, choose action. Let's do an attack. And we get our new message log. It no longer says that they died though, because it handles that with process damage results, and all it does is spit out this message. So we actually need to update this message if the target died, I think. So let's take this after damage, where we have their status. And let's make a little if statement here. If, and we basically want this results to, we're doing an equals check though. If they're dead, we'll say that we'll just add it to the message. Okay, this is getting complicated real fast. Period. And then we want their name again. And then we want the died. Okay. So now that should give us a better message when we attack and kill something. There we go. Now it appends a target died, or whatever its name is. 1,000 damage inflicted on. Now this is the name of a target, and then it would say whatever its name died if it died. So our message is a little better there, and it's also modular enough to handle a lot of different potential cases that we could build up over time in our little game thingy. So there's nothing else to do. It'll just keep saying it died, because we don't have any way to destroy it or anything like that yet, which is maybe what we should start building next if we're going to continue this. But for sake of example, I think I've shown enough about return values and the basics of getting some little system going in C++. Another important thing we want to do here, since we're manually handling our memory just before exiting, or well, we'll improve this later. The program's going to exit anyway and destroy the data, so we don't necessarily have to really care about deleting this initial target thing right now, because it's going to do so right here anyway. But if this were somewhere in the middle of another system, we need to make sure we delete when we leave it, otherwise it's just going to sit there, or it could potentially just sit there. So it's kind of good practice to get used to of anytime you instantiate something with this new, you should have an associated delete somewhere. Now we could say there's only one target allowed at a time, and it's this initial target, and if it dies we delete it and reinstantiate it as a new target. So we could have some kind of system like that for a single unique enemy that keeps coming back, or we'll say an enemy slot rather, that keeps coming back, like a spawner or something. You kill it, it gets deleted, then it reinstantiates with a new thing. Now there'd be a lot of playing around with memory, so there might actually be a better way of doing it. Anyway, this has gone on long enough. Hope you guys enjoyed this live coding session about return values, where we have made somewhat of a little game where we can do some damage to a target. Hooray. Alright, well, if you have any comments, leave them below. If you like this sort of video, be sure to leave a like and I'll know that I should make more of these sorts of videos. And Matt out. Peace out.